Hi friends, welcome to my channel NM Learn Courses with Namani. Today we are going to see how to find the eigenvalues and eigenvectors for a given matrix. We know that first for finding eigenvalues we have to write the characteristic equation, that is nothing but modulus of a minus lambda I, which is equal to 0. Here we know that A is given matrix and lambda is the characteristic constant and I is the identity matrix characteristic equation. So now I am writing here A is the 8 minus 8 minus 2 4 minus 3 minus 2 3 minus 4 1 minus lambda into I is nothing but 1 0 0 0 1 0 0 0 1. So these are the matrix. So we have to write in a square box and for the determinant we have to write modulus, which is equal to 0. Okay, so from here I am writing 8 minus lambda. From this equation we will get 8 minus lambda. Here minus 8 minus 0, so no need to write 0. Minus 2 minus 0, so minus 2. So only diagonal elements will change. So minus 3 minus lambda minus 2. 3 minus 4 1 minus lambda, which is equal to 0. Okay, so first for the determinant, here 8 minus lambda into, we have to multiply these two and subtract with these two. So okay, minus 3 minus lambda into 1 minus lambda minus, here minus into minus plus, plus into minus minus, so 4 to the 8, we will get minus 8. So minus, here minus 8 is there, so minus into minus plus 8 into, we have to close this column and this row, so we have to multiply crisscross and we have to subtract each other. So 4 into this, I am writing directly, so no, okay, we will write one more step. 4 into 1 minus lambda minus, here minus into minus plus, 3 to the 6. Okay, minus 2 into, here 4 4 the 16 minus 16 minus 3 into this one, so 3 into minus 3 minus lambda, which is equal to 0. Okay, okay, and so for simplifying we need to make one simple step, like we can assume this is a first term and this is second term and this one is third term. So we will simplify each term and we will add together. Okay, so that we can avoid mistakes. So here 8 minus lambda into, so I am taking first term. Okay, so minus 3 into 1 minus 3 minus into minus plus 3 lambda, so here minus lambda plus lambda square minus 8. So here we have to simplify this, so 8 minus lambda into, plus 3 lambda minus lambda will get plus 2 lambda minus 11. Okay, and here we get 8 into this one minus lambda into this one, so we'll get 8 lambda square plus 8 to the 16 lambda minus 11, it's a 88 minus lambda cube minus 2 lambda square plus 11 lambda. So if you simplify this, we will get minus lambda cube plus 6 lambda square. So lambda cube and 6 lambda square is cancelled, and plus 16 lambda plus 11, 27 lambda minus 88, which is equal to 0. No, sorry, this one is first one and the second one is, so 8 into 4 minus 4 lambda plus 6. So here we will get 8 into 6 4 10 minus 4 lambda, so 80 minus 8 4 is 32 lambda. This second one and third one. So minus 2 into minus 16 minus of minus place 3 3s are 9. So minus of minus place 3 lambda, and here we'll get minus 2 into 3 lambda minus 16 plus minus 16 plus 9, we will get minus 7. Okay, from here 3 2s are 6 lambda minus of minus place 7 2s are 14. Okay, this one first term, second one, third one. So I am adding first term, second term and third term. We'll get minus lambda cube plus 6 lambda square plus 27 lambda minus 88 plus 80 minus 32 lambda, okay, plus minus 6 lambda plus 14, which is equal to 0. Okay, so here only lambda cube is one term, so here we will get minus lambda cube and lambda square remaining. This one is okay. Next 6 lambda square, no, so okay, plus 6 lambda square. This one also over, and lambda terms we have to see 27 lambda minus 32 lambda minus 6 lambda. So minus 38 lambda plus 27 minus 38 27, we'll get minus 11 lambda. Okay, and remaining lambda terms are cancelled, and here minus 88 plus 80 plus 14 plus 80 14 94 minus 88. So 10 minus 8 2 4 6. So here we will get plus 6, which is equal to 0. This equation we got from this determinant. Okay, so I wrote the equation here. Now we will find the factors for this cubic equation. So for finding factors for cubic equation, we have to convert this cubic equation to quadratic equation. So here we have to write the coefficients of this, like here minus 1 6 minus 11 6. So we have to check with the 1 if it is 1 minus 1 or 2 minus 2. If answer will come with minus 1, so we will stop here only. Otherwise we have to check minus 1. If it won't come answer, then we have to check with 2. So this is like trial and error method. So mostly the answer will come at 1 or minus 1. So first I am checking with the 1. So we have to write 0 here, and here minus 1. So 1 into minus 1 we will get minus 1. So here 6 minus 1 5. So 1 5 is a 5. So here we will get 11 minus 5 is minus 6. So 1 6 is minus 6. Here 1 minus 6 in. So you will get 0. So here we are getting 0. So no need to check minus 1 2. So we can conclude that lambda equal to 1 is the one of the root for this equation. So here we can write that lambda minus 1 into, so here this one is quadratic, minus lambda square plus 5 lambda minus 6, okay, which is equal to 0. Understood? And if you want, we can take minus common in this quadratic equation. So to avoid confusion, I am taking minus common. If we will take minus this side, so nothing will happen. So lambda square minus 5 lambda plus 6, which is equal to 0. Okay, here for 6 we can write 2 3s are 6. So here we are minus 5. So minus 2 minus 2 minus 2 we can write like this. So here we get lambda square minus 2 lambda minus 3 lambda plus 6, which is equal to 0. Here we can take lambda common. So lambda minus 2. Here we can take 3 common. So lambda minus 3 2s are 6, which is equal to 0. From here we'll get lambda minus 1 into, Here also we can take lambda minus 2 as common and we will get lambda minus 3 which is equal to 0. So from this we can say that lambda equal to 1, lambda equal to 2 and lambda equal to 3. So these are the eigenvalues for a given matrix. Now we will see how to find the eigenvectors for these values. Okay. The equation for the eigenvector is a minus lambda I into x bar equal to 0. So I wrote the a minus lambda I matrix and x bar is x, y, z. We can say that we can assume that x1, x2, x3 also x vector. Anything is okay. Okay. We know that lambda equal to 1, 2, 3 and these are the eigenvalues which we got for this matrix. Okay. And first I am for lambda equal to 1 we are finding eigenvectors. Okay. Substitute lambda equal to 1 in this matrix. Okay. Here we will see 8 minus 1 7 minus 8 minus 2 4 minus 3 minus 1 minus 4 here minus 2. So here 3 minus 4 1 minus 1 0. Okay. Here x y z which is equal to 0. This is lambda equal to 1 and just multiply this row and this column. We will get equation. So 7x minus 8y minus 2z equal to 0. Here 4x minus 4y minus 2z equal to 0. 3x minus 4y plus 0z which is equal to 0. Okay. So let z is equal to k. This method I am following from the since first video. So you can go through that videos and you can understand in better way. And z equal to k. So from this equation we know that 3x equal to 4y and from here we can say that x equal to 4y by 3. Okay. We got x value. So substitute x and z in any one of the equations. We will get y for y. So here I am writing in equation 1. So 7 into x is 4y by 3 minus 8 into y minus 2z is nothing but k which is equal to 0. So I am multiplying with 3 and I am taking this 3 into this side. So 7 4s are 28y minus 3 into 8 24y minus 3 2s are 6k which is equal to 0. So here we will get 28 minus 24 4y which is equal to 6k. From here y equal to 2 2s are 2 3s are so 3 by 2 k. We know that y equal to 3 by 2k. From this equation we find in terms of x value in terms of k. So 4 by 3 y is nothing but 3 by 2 k. So 3 3 get cancelled 2 2s are sorry. Okay. From here we will get x equal to 2k. So for lambda equal to 1 for this eigenvalue we get eigenvectors are x, y, z which are x equal to 2k and y equal to 3k by 2 and z equal to k. So these are the eigenvectors for a given eigenvalue. So we can take k common. So from here we can write 2, 3 by 2 and 1. If you k equal to 2 then multiply with 2. So 2 2s are 4. Here 2 2 get cancelled so 3 and 2 1s are 2. This is the one of the eigenvector for this equation. If you take let k equal to 4 something so then 4 2s are 8. Here 3 by 2 into 4 2 2s are 4 so 2 3s are 6 and here 4 1s are 4. This is one more eigenvector. So like this there are so many eigenvectors for a given single eigenvalue. In this way we can find the eigenvectors for given matrix. Similarly we can find lambda equal to 2. Okay. So we will see here now. Now we are substituting for lambda equal to 2 in this matrix. So now substitute lambda equal to 2 in this matrix. So we will get 8 minus 2, 6 minus 8 minus 2, 4. Here minus 3 minus 2 minus 5 minus 2, 3 minus 4, 1 minus 2 minus 1. Here x, y, z which is equal to 0. So I am going somewhat little bit fast. So if you don't understand, please keep your video in 0.5x something speed, so then you can follow it. So here I am multiplying with this row and this column. So we'll get direct equations. I am writing 6x minus 8y minus 2z which is equal to 0. Here 4x minus 5y minus 2z equal to 0. Here 3x minus 4y minus z which is equal to 0. Okay. So let similarly let z equal to k, and for finding relation between x and y, so just I am removing. So this, if you say this equation is 1, this equation is 2, so I am subtracting this minus this, so that this 2z will cancel and we will get the relation between x and y. So we can find the similar way of this. So I am taking 1 minus 2, so we will get here 6 minus 4, 2x minus 8 plus 5, we will get minus 3y minus 2z plus 2z is 0. So from here we will get x equal to 3y by 2. So substitute x in this equation, we will get 6 into x is 3y by 2 minus 8y, z is nothing but k which is equal to 0. So 2 3s are 6, 3 3s are 9y, 9y minus 8y. So we will get y equal to 2k. So substitute this y equal to k in this equation. So we will get x value in the form of k. So 2k. So this 2 will get cancelled. So from here x equal to will get 3k. Okay. Sorry, x equal to 3k. So for lambda equal to 2, the eigenvectors are x, y, z are x is nothing but 3k, y is 2k and z is k. So we can take k as common and 3, 2, 1. So this is the eigenvector for a given eigen value, and k may be rational, irrational, any value. Okay, in this way we can find the eigenvector. Now we will see for lambda equal to 3. So I am substituting in that equation 8 minus 3, 5 minus 8 minus 2, 4 minus 3 minus 3 minus 6 minus 2, 3 minus 4, 1 minus 3 minus 2. So here x, y, z which is equal to 0. So again I am writing equations 5x minus 8y minus 2z equal to 0, 4x minus 6y minus 2z equal to 0. So 3 into x, 3x minus 4y minus 2z equal to 0. So similarly again we can assume let z equal to k. So for finding, so we can subtract 1 minus 2, 5 minus 4, so 1x minus 8 plus 6 minus 2y. So this z, 2z equal to cancel and this one equal to 0. So from here we will get x equal to 2y. Okay, and substitute this in any one of the equations, we will get z value. So 5 into x is nothing but 2y minus 8y minus 2z equal to 0. From here 5 to z 10y plus 10y minus 8y minus 2 plus 2y minus 2z equal to 0. From here we get y equal to z, and we know that z equal to k. So y equal to k we know that we got, and y equal to k means x equal to 2k. So the eigenvector for this lambda equal to 3 is So x, z are x is 2k, y is k, z is also k. So if you take k common, then you will get 2, 1, 1. So this is the eigenvector for lambda equal to 3. In this way we can find the eigenvalues and eigenvectors for a given matrix.